So what are event loops and how do they work? So in this video we'll try to understand what are event loops in JavaScript and how they help in scheduling and executing, and how it kind of like sets up the base for the async behavior of JavaScript in general when it's single threaded at the same time, right? So in the last video we went through an analogy of a restaurant to kind of build an intuition around event loop, and we'll be using that same analogy here. I'll just walk you through it once if you haven't watched it. I'll link it somewhere here as well if you want to watch it. So what we took an example of was a restaurant. So basically a restaurant has customers coming in. The customers have orders and they have micro orders. Let's say, I'll explain that what that means. So what order is, let's say they order some spicy food. Micro orders can be like they ate the spicy food and now they need water, right? So it's something associated with the main order. And then every order goes to the chef, and what the chef does is the chef will prepare the order in sequence. Some order might need some baking or some ovening, like I don't know what it's called. Maybe ovening is not even a word, but yeah, that's not the matter here. So maybe some order might need some other things which takes its own like sweet time. The cook cannot control it, but that doesn't mean the cook will have to wait for that to finish for it to move to the next process. So let's say the cook is baking a cake or something. So the cook will just do everything, put it inside the oven and move on to the next order until it's done. And when it's done, it will take care of it, however, right? So we discussed that as well. So now let's kind of bring that situation in and put it here. So what the event loop has is, it has a main task queue and it has a micro task queue, right? And the event loop pulls in tasks from the main task, and every main task, most of the main tasks has some micro tasks associated with that as well. So when you are pulling the main task, you put them in the micro task queue as well and kind of execute them all together. So once you are done with the main task, you execute the micro task associated with the main task as well. And now let's say you are using something like AJAX calls or set timeout function or anything as such which involves some kind of waiting. So that async behavior that we are talking about, right? So that event loop doesn't handle on its own. It pushes it to, or it delegates it to web APIs. So the web APIs are kind of provided by the environment that your JavaScript is running in. So let's say you're running it on the browser, then maybe this should provide by the browser itself, which is kind of disconnected from the main thread, right? So it's separate from the main thread. Since JavaScript is single threaded, it cannot run multiple things on the same thread. So it delegates some responsibilities to these web APIs which run on different threads, right? So that's what. Then when the web APIs are done, they will again have the result pushed to the main task queue. So every set timeout function has a callback, or everything, like every promise has something like you need the result back. So just take an example that everything has this callback function that once this task is done, once this time taking task is done, do X. So that do X aspect is called the callback, right? So that callback will be again pushed to the main queue, main task queue at the end of it, of course. Then what happens is when you are done with all of them, it will the callbacks turn will come, it will get executed, micro tasks and all executed, done, all set. So that's a very basic way of understanding how the event loop works. Now I just wanted to also walk you through a basic time graph of how it might look like when you're executing something in the event loop, right? So let's say we have this graph. This is time plotted, like this is some 0 to some x value, right? So we have time here. Then let's copy this and let's have it here. Let's copy this, and we have the second thing here. We have the main task queue. Let's call it empty queue, capital empty queue, and we have the micro task queue. Let's call it small empty queue. After that, what we have is the web APIs which are outside the main thread. So let's draw a box around it, right? I don't think I need a background. Cool. So this is outside the main thread. So this kind of represents the things that will take time to done, and the event loop can delegate these things to the web APIs, right? So now what happens is you have this you have some task called T1, let's say, that comes in from the main thread at task, let's call it X1, since time is T and it's kind of confusing. So let's say we have task X1, it's coming from main task queue. So what happens is like with time, it is first this execution happens. And then we move to empty queues. Cool. So when sorry, why did I draw the graph here? I'm not sure about. That's what. So first we have the task X1 that is from the empty queue, that isn't executed, and then we have the micro tasks associated with X1. Let's say X1.1, X1.2 that isn't executed, right? So these two things we have. Then maybe we have another task called X2. X2 is pulled in from the main task queue, and first of all the tasks are executed, main task, and then all the micro tasks associated with X2 are executed as well. Let's say it has just one micro task, which is possible, of course. I mean, depends on. Then let's say we have another task called X3. We copy this whole thing, we paste it here. Same logic, nothing different. So now let's say X3 has a set timeout function, right? So what will happen is, once it's done, it will push that set timeout thing to web APIs, because it's gonna take its own sweet time, and if the main thread is blocked, it won't be able to move ahead, right? So it will take its own sweet time, and let's say let's copy this. Let's say we have this set timeout function here. Set timeout, it has a callback called C1, and it has a delay of maybe 3000 milliseconds, right? So this is what we get here as well. Now what will happen is this duration. Let's say, for example, let's say after 3000 milliseconds it's done, and ms or something. So after that it will again push it to the main queue itself once it's done after this amount of time, and in the meantime this will keep on going, this won't stop. So X4 is brought in from the main queue, and this thing will keep on going, this thing won't stop even if this is running, but it is running in somewhere else. It's not running in the main thread. So the main thread won't sit idle. The main thread would keep on pulling processes from the queue and keep on running them while this is running. That's what kind of brings in the async nature of JavaScript as well. So yeah, there is that. Now the next thing is, after this is done, let's say we have C1, and then we would have maybe X5 runs for X5 as well. And since this was the callback was C1, right? The callback that was returned here was C1. So maybe after X5, C1 runs. Let's extend this. Yep. So we have this as well, and we start from here. After 10 milliseconds we push it here, and then X5 runs, and then C1 runs. So let's draw that as well. We have X5, and then we have C1 below it. Now if we kind of break it down and we move to what the queue might look like, right? So what's the state of the queue and how it changes with time. So at the beginning, what we had in the queue was, let's give it some color as well. Yep. So at the beginning, what we had was, we have how many processes? We have 5. Okay. So at the beginning, let's say we had till X5, X4, X3, X2, and X1. Cool. So in the first iteration, when it pulled in a task, it pulled the next one, so this won't be there. We have x2 now. Yeah, so in the next iteration, we would pull in x2. So in the first iteration we would pull in x1, so x1 is gone, and in this period of time when x1 is being processed, the state of the queue will be this. So we have x2, and then we pull in x2, then the state of the queue will be x3 is here. It keeps on going, same thing for here. x4 is there, x4, and then when you pull in x4 you have x5. But before pulling in x5 and after C1 is pushed, that has a different state. So as you can see, we have x5 here, but you can see the callback gets added to the end of the queue as well. So even if even if C1 is pushed, it's not instantly executed, it has to wait for its turn. So since x5 was before C1, x5 is executed, and after x5 is executed we have C1, and after C1 we are done. So that's how an event loop works in JavaScript, and at least the rough estimates of it. And then in the next video I'm thinking of sort of jumping to an implementation of this in JavaScript, so that we are able to understand it better and how we could achieve such a behavior if we need to emulate it in our use case as well, right? So that's what. So yeah, that should be it for this video. I think I hope you folks found it helpful, and if you learned something new, drop a like, share with your friends. If you have any feedbacks, please leave the feedbacks. I would be happy to incorporate them into my future videos. And yeah, see you folks. Bye.